angle of refraction is a constant quantity for a given pair of media. And the constant, if you put the value, will be equal to relative refractive index of medium 2 with respect to medium 1. That means what they are saying, sine, it implies that sine I upon sine R is actually equal to n to 1, or in terms of absolute refractive index I can write it as n2 by n1. In terms of speed of light I can write it as v1 upon v2. Also, if in terms of wavelength we have to write, we'll write it as lambda 1 by lambda 2. That means sine I by sine R is equal to n to 1, or sine I by sine R is equal to n2 upon n1, or sine I by sine R equals to v1 by v2. Or we can also write it in terms of wavelength of light in the two media. So sine I by sine R can also be given as wavelength of light in medium 1 upon wavelength of light in medium 2. I hope all these denotions are clear to everyone. Okay? Lambda 1 and lambda 2 are the wavelength in the two media. Wavelength of light. This is Snell's law. These are the two laws of refraction. You all have written?
Just a second.
Yes. Okay.
Done.
Done? See. Now, we can also write down, so just for you to remember. When you have to give the statement of Snell's law, what you have written in the last page, you have to write in that way. That Snell's law states that ratio of sine of angle of impedance to sine of angle of refraction for a given pair of media is always constant, which is equal to n2 by n1 and so on. Okay? But when you have to apply Snell's law in question, it will always be easier for you to remember that for a given ray of light passing through various mediums. Okay? Write down, for a given ray of light passing through various mediums. It can be two or more than two. Okay? Mediums or I think various media. Passing through various media. Different media. Passing through different media. Okay? The relation is given as Snell's law is given as Snell's law can also be written as n into sine that the ray makes in that medium will always be constant. What it means? It means that product of refractive index of that media and sine of angle that the ray makes with the normal in that given media will be constant. It means when it moves to another medium. So let's discuss this point. It means like this. Say we are having these interfaces, parallel interfaces we are referring to. Because these are parallel interfaces separating different optical mediums. Say it is this represents an optical medium 1 having absolute refractive index n1, having n2, this is for n3, this is n4, this is n5. Okay? Then say a ray is incident. This light is, this color is visible to all of you? Yellow color? Yes. Okay. And so the ray is taking different paths. Like this. These are the normals at the interface. Okay? And so here is I1 and reflected at R1. On the other interface, incident at I2, reflected at R2, incident at I3, R3, I4, R4. Okay? But in geometry it is clear that here I2 will be equal to R1, here I3 will be equal to R2, and I4 will be equal to R2. Anyone having doubt in this one? Clear by geometry? Normals are parallel to each other because interfaces are parallel, so normals will also be parallel to each other. So this becomes alternative interior angles, no?
Yes, sir. Without I1.
Yeah. Now, what this law says, it says that product of absolute refractive index of the medium and sine of angle the ray makes in that medium will always remain constant. That means if you move to next medium, absolute refractive index of that medium and the product and multiplied by the sine of angle the ray makes in that medium will always be constant. That means every time the value will be equal to each other. So that means if this product will always be constant. So that means in first medium the value will be given as n1 into sine I1. Okay? And when you move to second medium, the value will be given as n2 into sine I2. When I move to third medium, the value will be given as n3 into sine I3 and so on. Because these all are constant, that means having the same value, that means they are equal to each other. Okay. Now since I2 is equal to R1, I can also, using these two, can get the same result. N1 sine I1 equals to N2 sine, I can, instead of I2, I can write it as R1 because I2 is equal to R1. So rearranging, I am getting sine I1 upon sine R1 is equal to N2 upon N1. That means refractive index of medium 2 with respect to medium 1. Am I getting the same result? Snell's law? Ma'am, how can you say that I1 is equal to R1? This will tell that why I2 is equal to R1.
Alternate interior angles. As the normals are parallel to each other.
Got it? Yes, ma'am. Okay. So by this, remember it in this way, it will be easier for you to apply. Okay? If you remember by the normal relation also, it's well and good, but you can also remember using this figure. Okay. Now, say, just like now you can get questions like this, like I've drawn the figure over here. If I ask you, Just by observing the figure, can you tell me that which one will be the rarest medium? And from the figure, which medium will be the rarest one?
The medium 1.
Medium 2, ma'am.
Medium 2. And which is densest? Densest medium?
Medium 3.
Medium 3.
Because we have done that the ray will bend away from the normal, it moves to a rarer medium, and it will bend towards the normal, then it will move in a denser medium. So if you see, the smallest angle with the normal is found in medium 3. So medium 3 is the densest of all, and the maximum angle is found with the normal in medium 2. So medium 2 is rarest of all these, which we have shown. Okay, is this point clear? So just by observing the figure, you can tell that, of course, we won't be able to give the numerical value, but comparatively, we can tell that which medium will be rarest and which medium will be the densest medium. Okay, you can get such questions also. Then, state is given to us that, I'll give you some values here. Say, this is 1.2, this is 1, this is 2, this is having certain values, okay? And it is given that I1 is equal to 30 degrees, okay? So to find out the value of R2, find out. Okay, so how you will proceed? So now, instead of solving one by one and reaching to this point, that means solving for first interface, then for the second interface, using this result, we can directly equate these two. That means absolute refractive index of medium 1 into sine I1 will be equal to absolute refractive index of medium 3 into sine. I3 or R2 are equal to writing at R2. Putting the values, it will be 1.2 into sine 30 equals to 2 into sine R2. 1.2 into sine 30 means 1 by 2 equals to 2 into sine R2, or we'll get here 0.3 equals to sine R2. So R2 can be given as sine inverse of 0.3. That means, or you can also leave it as sine R2 equal to 0.3. That can be the answer. This is also a way of writing the same answer. Okay, that I have taken the sign on the other side of the equation. So if it goes to the denominator, we'll take it on the above, so the power will become minus 1. The sine inverse of 0.3 is equal to angle R2. So this is how I can write it. So this is the way to get a multiple. Yes, beta.
Ma'am, the sine inverse from the 17.45.
Of course, but normally you won't be getting calculator to do that.
Yes,
so that's in this way we'll write. And later on in higher classes, then they will be providing you the table and all. There you can do the calculation of it.
Yes. Ma'am, Olympiad's calculator is allowed, right?
So this point is clear. This question is clear to all of you. Okay. So what is it is given that N1 equals to N5. Then what is the relation between I1 and R4? If N1 equals to N5, then I1 and R4 will be, just check and tell me.
Ma'am, all this is only for when all the lines are parallel, right, ma'am?
Yeah, when the interfaces are parallel.
Yes.
I1 is equal to R4?
Yeah, I1 is equal to R4. Now, when the light comes back to the same medium, we say it as emergent ray. So you must, if you have not heard, you will learn this thing that incident ray will be equal to emergent ray. Why so from here only we are getting it? Because if we compare that N1 into sine I1 will be equal to N5 into sine R4. Now since N1 equals to N5, so that means sine I1 equals to sine R4, implying that I1 will be equal to R4. Now when the light comes back to the same medium, we will refer this light as emergent ray. This as incident ray. So when your interfaces are parallel, so incident ray and emergent ray are, angle of incidence will be equal to angle of emergence. So we are getting here angle of incidence equals to angle of emergence. We'll discuss in year schools also, we'll discuss it in case of glass slab. If you put a glass slab and the ray is angling from here to the glass slab and coming out into the air again, then the angle which the ray makes in here with the glass slab, and when it comes out, the angle of emergence, the two angles will always be equal to each other because the two interfaces are parallel, and the refractive index of the mediums are also equal. So using a Snell's law, we can easily prove that angle of incidence will be equal to angle of emergence. Is this point clear to everyone?
So what is an emergent ray?
Emergent ray, that means a ray emerge out into the same medium from which it is incident in the medium through which it is incident into the other transparent. If it comes out, comes back into the same transparent. We will call that ray as emergent. It is emerging out from the given optical medium back to the original medium. Okay? So is this point clear to everyone? Now, I think so with this we have discussed the refractive index. We have discussed the concept of this refractive index, and then we'll be applying this refractive index in the various questions. Let's do some questions here. Okay, easily we'll do one thing, and that is one concept, and that is angle of deviation. In this case of mirrors, we have discussed what was the value of angle of deviation. In case of refraction, we have discussed what was the value of angle of deviation. Yes, we tell me. Angle of deviation in refraction we have discussed. What is angle? What do you understand by angle of deviation? Yes.
The angle by which the incident ray deviates after changing medium. So it's basically I minus R in this case.
So this is angle of incidence I, and this is angle of reflection R. This was the original path which we have shown dotted. So by definition of angle of deviation, you know that it is angle by which the ray get deviated from the original path. Take a bending of that path, bending of light to a certain angle. The angle through which the path of the light gets changed or bent. So that is the angle of deviation delta. So clearly from figure it is clear that delta will be equal to I minus R or R minus I, depending upon whether it is bending, it is moving from mirror to denser or denser to mirror. Okay? So angle of deviation will be given as I minus R or R minus I. That means difference of the two. We'll subtract the smaller angle from the greater angle to get the angle of deviation. Also we can get the sense of deviation in the similar way like we have done in case of mirrors also. So all these points are clear. कितना टाइम लगेगा? This is the question. Yes, there is a question in the book. Yes, beta, what is the which question number you are asking me to solve?
Question number 94.
An object 3 meter tall is placed. This question is there in your book. Okay? An object of 3 centimeter tall is placed at a distance of 3 meters from the wall. How far from the wall must the concave mirror be placed in order that it may form an image of same 9 centimeter high on the wall? I think there is a problem in the language of the question. Plain की image कहाँ से आएगी? The object 3 centimeter tall is placed at a distance of 3 meters from the wall. अच्छा. How far from the wall must a concave mirror be placed in order that it may form an image of the object 9 centimeter high on the wall? नहीं बेटा, I think so. No, there is a misprinting. Instead of concave mirror, and so they उनको यहाँ पे convex lens देना चाहिए था.
Ma'am, they have solved it at the back point, so I was not able to understand that.
So either they are saying that, how can it be possible? Just think of a situation. I don't know how they have solved this. Just give me the solution because from the language that I'm getting it's this. They're saying this is the object which is 3 centimeter, and here is the ball which is at a distance of 3 meters from the object. And how far from the wall must the concave mirror be placed? Okay, write this. I think so like this. They must have given it. On the other side, it can happen. That image of the object can be formed on the wall. Okay, as a this is the case which can be formed. And they have not given us the focal length of the mirror, or then a mirror no, is not given. Yeah, this can be the case. The object distance is यहाँ पे u ले लेते हैं. So object distance will be u minus u, and image distance will be minus u plus u. And then we can find out focal length.
Ma'am, we are given the magnification.
And then the magnification. Magnification is given to be. And of course, this question in this magnification, the image form will be inverted. So magnification will be minus v by u. That will be equal to minus में आएगा 3 ना?
Yes, ma'am.
Minus 2. So now you can solve it for.
Okay, ma'am.
दोनों को relate करके you can find out value of u. Directly you can find out value of u from here.
Okay, ma'am.
ठीक है. Clear this question?
Yes, how are we getting magnification? Is it given in the question?
Yeah, it's given in the question. The question they are saying that image formed is 9 centimeter high on the wall.
Yes,
And because it is formed on the wall, it will be a real image. It will be inverted. So magnification will be
Yes,
minus. Okay. So revise all the concepts we have discussed today of refractive index. Okay, thoroughly. And then from the next class, we'll be doing some questions on refractive index, angle of deviation only. And then we'll move to lenses. No, refraction in plane mirror करेंगे. Then we'll move to lenses. First we'll complete the refraction in plane surfaces, and then we will move to curved surfaces and start with the lenses.